we've seen now that the equation y prime plus p of ty equals 0, which is first order, highest derivative is the first, linear, no squares of y's or y primes or any of the derivatives of y, and homogeneous, equal to 0. This is a first order linear homogeneous equation, and now we have a general method for solving this equation, and that is simply that y of t will equal e to the negative integral p of t dt. So that is our general solution to this equation. Now we ask the question, we've got 4 equations here. Among these equations, which ones are first order, linear, and homogeneous? Consider the first equation. Now we've got to put it in the form y prime plus something times y equals 0, so the first thing we have to do is divide out the coefficient of y prime, and that's going to give us y prime plus sine of t equals 0. Now what happened here is our y divided out. So is this first order linear homogeneous? No. Our y term is absent. Looks like I wrote the word yabsent there, but it means y is absent. Let's consider this equation. T equals y prime plus t squared y. We can put this in the form y prime plus t squared y. Now if this was equal to 0, then t squared would be our p of t function, and we would have this function in the right form. However, we've got this pesky t here. We could put this on either side. I'm just going to put it on this side. Our left-hand side matches the form, but with this t on the right-hand side, it's not equal to 0, so it's not homogeneous. It is first order and linear, but it's not homogeneous. Now it turns out that we'll have a technique, and a relatively straightforward technique once we get used to it, for solving a non-homogeneous first order linear equation, but we don't have that right now. Consider this equation. Cosine t y prime equals negative sine of t y. Well, if we divide through by the cosine of t, we're going to have a sine t, excuse me, fall allergies, sine of t over cosine of t in front of the y, and then we can bring that over to the left-hand side and fairly easily see that this is sine of t over cosine of t y. So we have y prime plus the sine over the cosine equals 0, with the condition that cosine of t is not 0. Now this is a perfectly good function, p of t, sine of t over cosine of t, and as you should know, that's just the tangent of t. It has its derivatives and antiderivatives, which are a little bit complicated, but not much. So this does fit our form, and we're okay. What about this one? Well, at first it looks okay, but we got the square on y. Y squared is not linear in y, so no. This one is a yes.